Meet Lawny. It's a lawnmower with a first-person view camera that allows you to cut grass while controlling a remote-controlled robot. I've built it using a Raspberry Pi, several electric motors, several relays, several H-bridges, a camera, and it can be controlled from any mobile phone or a desktop. It's a complete do-it-yourself guide how I made it. And you can build exactly the same thing on your own. There is nothing complicated. Moreover, you can find all links to all components in the description below. The project's main idea is to control a lawnmower from your phone and see exactly the same picture in real time. Of course, nothing goes according to plan in real life, so I've made tons of mistakes and improvements during this process. You will see them all. So let's start with an overall review of electrical components and their relations. I have a steel razor trimmer head. If I add an electric motor to it, it will be a grass cutter. The motor will rotate the blades and they will cut the grass. Really simple. If I want to control the motor, I need a relay and a controller. In my case, I used Raspberry Pi 5 because I had it. Instead, there could be any Raspberry device that supports a pulse width modulation and camera. That will be a static lawnmower. But I want to cut grass everywhere, not just on the one spot. And I want to be able to move the mower left and right. So I am adding 2 more electric motors. The construction will be heavy, so I need power, not speed. And I will use windshield wiper motor from a real car. They can be found on Amazon or you can grab them from any pick and pull stations. Next, I need to control speed and rotation direction, so I am adding several H-bridges. I have a separate video that explains how to control a motor with an H-bridge. You can check it out on my channel if you want. The first limitation is that in order to control a single motor, I need 2 pulse width modulation channels. But I have 2 motors, which means that I need 4 channels. To solve this problem, I'm adding 2 more relays that will switch the signal between pins. I will explain how it works in the connection schema section in this video. Going further, I need to see where the lawnmower is going. So I'm adding a camera module to the Raspberry Pi. Additionally, I need some power sources. To prevent power drop from element that consumes a lot of current, I will use a separate battery for the motors and a power bank for the Raspberry Pi and electronics. And finally, I will control this system from a mobile phone with a cross-platform application through Wi-Fi. It looks kind of mad, but it's not a connection schema. It's just a schematic explanation of the system. It will be simple in the connection section, I promise. I have a piece of plywood. I also need to cut the bottom surface and walls. Some walls will be a bit taller. So now I'm measuring and sketching the future elements. Next, I need to cut it apart, and a saw will help me. I was never a great carpenter, so my cuts are terrible. Luckily, I can fix the shape with a sander. I will drill a hole in the middle of the bottom plate to accommodate an electric motor. Next, I want to attach walls to the plate. I will use wooden bracket connectors, but before that, I need to do a lot of drilling again. And finally, I can assemble everything together. Let's turn it on and see the results. And it's spinning. Okay, I have razors with a motor, but it's a static block. To move this cutter, I need to create the rest of the body, which will hold the cutter box and allow me to move the whole construction left and right. I will use a 3-wheel setup, 2 front wheels and 1 rear. If the left wheel has more speed, the lawnmower will move to the right. If the right wheel has more speed, the lawnmower will move to the left, and the rear wheel will be turned accordingly. And finally, if the speed is equal, it will move straight. I am starting with forming the sides of the body. I need to cut them from plywood. Traditionally, my cuts are terrible, so I will use a sander again. When the sides are done, I add 2-car windshield wiper motors. These electronic motors have a gearbox with more torque and will work better with a heavy project. I need to add 4 holes for each motor, bigger for the shaft and smaller for the bolts. Next, I need to make the front box for the electronic components. This box should be sealed and will keep the components safe from moisture and grass. Additionally, I'm adding the rear side. It should hold the third wheel. And now I need to screw the side parts to the crossbars. Finally, it's time to add wheels. I found nothing smarter than hammering coupling nuts into the wheel. Of course, the wheel had cracked. Of course, it was a terrible idea. Finally, the third wheel complete the moving part of Lawny. To allow for cutting grass at different heights, I will create 4 rectangular holes in the mower deck. The cutter will be attached to the sides with bolts, and these holes will enable its vertical adjustments. The final accord is to place all electric boards on the surface of the inner box. And of course, we need a switcher. The next stage is painting. I bought the cheapest white paint in Home Depot and took some color pigments from my basement. And it was an epic fail. Lawny is meant to be blue pearl, like a Subaru STI. However, I am even a worse painter than a carpenter. I was able to make the color white with blue. It was not even close to Subaru blue pearl. Luckily, my wife had saved me with additional blue pigment from a dollar store. First, review how to control a motor with one pulse width modulation signal and one GPO using an H-bridge and a relay. I have a 12 volts power source connected to the H-bridge module. An H-bridge connected to the electric motor, but the motor doesn't receive any current yet. To make it rotate, I need to connect ground to the H-bridge and send pulse width modulation signal to one of the input pins. If I send the signal to the input 1, the motor will start to rotate. And if I send the signal to the input 2, the H-bridge will change the current polarity and the motor will rotate in the opposite direction. I can add a simple relay to be able to control the H-bridge from the Raspberry Pi. Next is the whole schema of the system. I will have two electric circuits. The first one is a 5-volt circuit with controller elements. We have a Raspberry Pi, it's the brain of the system, and two H-bridges to control Lawny movements. These bridges requires two additional relays because of the reason we spoke a few minutes ago. I also added one relay to control a grass cutter motor. All of these components require ground. So I will create a ground bus analog, a single wire from Raspberry Pi to the ground pin for each element. Next, I will connect a 5 volts input from Raspberry to relays. These relays will be controlled by GPOs 5, 6 and 7. So I am connecting the input pin of relay 1 to GPO 5, relay 2 to GPO 6 and relay 3 to GPO 7. Now I want to send a pulse width modulation signals to relays 1 and 2. I will connect the PWM1 port of the Raspberry Pi to the communication port of the first relay, and PWM0 port to the communication port of the second relay. Two outputs from the first relay will go to the H-bridge inputs. The same applies to the second pair of controllers. And here is the second circuit of 12 volts elements. A battery. Such a form factor is widely spread in bikes. Two electric motors are for Lawny's movements, and one is for grass cutter blades. Again, I have a ground bus connecting all these elements' grounds. I use sticker lines for a 12 volt connection. Then I am adding a positive bus that has a switcher at the very beginning. Connects to the positive pins of both H-bridges and goes to the relay 3. Then I connect the output from H-bridges to motors 1 and 2. And polarity in this case doesn't matter. The H-bridge will change it. And finally I am connecting the cutter motor to the relay. That's pretty it. Do you remember that I said that it would be easy on a connecting schema chapter? Yep, I lied. Life is complicated, sorry. And now we make that schema happen. I'm starting to place electronic elements in the box. And here is another epic fail. The holes on the Raspberry Pi are too small for all my screws, or the screws are too short to hold the Raspberry Pi in plywood. There were several options to fix this. The best option was to buy appropriate screw, and the worst idiotic option was to drill the Raspberry Pi. And guess what? Yep, I am drilling it. Now, when all boards are in their places, I am creating a wire to connect all 5 volts boards. And of course, it's better to double check the pinout schema. After the ground bus, I'm making a 5 volts positive bus. And connecting it according to the same pinout schema. Next, I will connect GPIO 5 and 6 to the input of relays. Now it's time to connect pulse width modulation pins to the relay's communication channel. And then I connect both outputs from the relays to the inputs of H-bridge 1 and 2. Finally, I'm connecting GPIO 7 to the third relay. All my 5 volts elements are connected and look like this. Going further, I'm adding the first windshield wiper motor. And connecting its black and yellow wires to the H-bridge motor's output. Then I will do the same for motor 2. Now I'm connecting positive and negative inputs of H-bridges to the 12-volt circuit. It's time for the cutter motor and its connections. I'm using several nuts and washers to hold the blades on the motor. It's really important to screw it tight to avoid unexpected damage to the surrounding. It seems like the main part of the Lawny is ready. Next I will add connectors for power wires. It's important to be able to easily disconnect motor and batteries from the rest of the system. And last but not least, I'm adding a physical switcher. It will be very helpful if we can disable all the motors in case of losing control with a single button. The remaining part is to connect all wires and add a battery and power bank. Finally, I can conduct a few tests. First, let's try to enable the cutter motor remotely. Second, the test in the basement. And third, the outdoor test. And yes, it's another epic fail. These wheels don't have enough of grip to move and turn the mower. Additionally, the crack in each wheel doesn't add any durability. So it's time for the first upgrades. I can throw out old wheels and grab a better pair. Now I will not hammer coupling nuts inside. I will heat and pressurize them. See, I'm learning. Next is to screw tight these wheels if I don't want to loop them. The next upgrade, the rear wheel. It also has a bad grip and it's too small for Lawny. Moreover, it doesn't look great. And now we're talking. The remaining part is to install it. I'm drilling and cutting again to make it reliable. And now the painting time again. The process is the same, so I will cut the video here. My wife saved me the second time by painting. She created such a nice face. I'm adding a camera to the front surface. First, I need to place a holder and screw it to this plate. Second, I will connect a camera cable to the Raspberry Pi. Finally, I can do another Lawny test. And you can see the result. The grip is much better, but still not enough to handle tall grass. Back to the basement. Now I know how to fix it. I have a lot of wooden screws. No needs to spend tons of money on expensive wheels if I can go into Mad Max mode and tune current rims. And the last improvement for this video is blades. To be honest, the electric motor is too weak to cut tall grass. It stucks and the motor overheats and it doesn't work as intended. Luckily, I can replace my previous blades with a solid option, and I'm sharpening them as much as possible. The results looks aggressive, and that's awesome. In the end, I could cut tall grass and navigate Lawny through all obstacles without any issues. Lawny could easily do the regular cutting. With an overgrown lawn, It will require more time, but eventually the lawnmower will tackle it as well. The current motor could be more powerful, but it depends on the grass and how often to use it. That's it. You can find all links to the components from this video in a description. Let me know in the comments if you want to know the software part of the system or what you think in general. Traditional, like, share and subscribe. Thanks for watching.